Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Regional Renbans by Derek Leclerc, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. The 3x3 box borders divide a purple line into segments with the same sum. So that's the regional part of, because of the regional Renban, because they are region sum lines, basically. We also have each segment is also a non-repeating consecutive set of digits in any order. So that's the Renban part of these regional Renbans. So you could have something along the lines of, say, a 9 here, and then this is 2, 4, and 3 here. And that adds up. So 2, 3, and 4 form a Renban, because that's a non-repeating consecutive set of digits in any order. 9 also forms a Renban. It's just a Renban of 1, which is a consecutive set of digits, which is the case for one digit. And this would be valid, right? Because you would have 9 here and 2, 3, 4 here, adding up to the same sum. And 2, 3, 4 forms a valid Renban, and 9 forms a valid Renban, which is why that works. So basically, the box borders, each line is a region sum line. And then the box borders divides that region sum line into segments, which must be valid Renban lines, I should say. So that's another way of looking at it. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this can only be 6 or 9. Because to have 3 unique digits, form a Renban, and be able to add up to a single digit, you can either have 1, 2, 3 or 2, 3, 4. So this is guaranteed to have 2 and 3 in them. So there's no more 2 or 3s in that box, and this has to be a 6 or a 9. This is 4 digits here, and this is 5 digits here. Anytime you have 1 digit with 2, though, you could have 1 and 2 adding up to 3, 2 and 3 adding up to 5, 3 and 5 adding up to 7, or 4 and 5 adding up to 9. So this is 3. These digits, which have 1 on one side and 2 digits on the other side, have to be 3, 5, 7, or 9. Okay. And the digits adding up must be 1 through 5. Okay. Interesting. Oh, for this Renban, on this Renban, anytime you have 5 or more digits on a Renban, you're guaranteed 5 has to be on that Renban. Because if it's not on the Renban, the problem is it just doesn't work, right? To have a 5-length Renban, it must either, or greater, it must be 1, 2, 3, 4, 5. 2 through 6, which includes a 5, 3 through 7, which includes 5, 4 through 8, which includes 5, or 5 through 9, which includes 5. So we're guaranteed a 5 on this Renbans. That eliminates 5 in the rest of the box. So this can no longer be 4 and 5, adding up to 9 here. Okay. These are 4 digits, which must add up to a sum. And they always have to be even. Because since they're all consecutive, you have the lowest. It could be, like, say, 4 through 7. That's going to be 4, 5, 6, 7, which adds up to 22. Or it could be 5 through 8, which adds up to 26. Or it's 6 through 9, which would add up to 30. But each of these sums is going to be even, which means these sums have to add up to an even sum. And it has to be 22, 26, or 30. Well, 22 and 26 do not work. How do you add up to 26 with 5 unique digits when they're all consecutive? You can't. 22 divided... So essentially, there's going to have to be one middle digit, which is essentially what it averages out to for the other 5 digits. Well, to get to 22, that's 4 point... It just doesn't work. Basically, it's multiplied by 5, right? Because it's a so the middle digit here on this Renban, you're going to have one that's above it and one below it, and then one that's 2 above it and one that's 2 below it. Well, they all collapse. If you sum them all up, that's essentially the same as the middle digit times 5. Obviously, so that means the sum has to be divisible by 5, which means this is guaranteed then. This sum must be divisible by 5, and the only sum that these 4 can be divisible by 5 is 30, which is 6, 7, 8, 9. So 6, 7, 8, 9 means the middle digit here has to be times 5. It's 6. So it would have to be 4, 5, 6, 7, 8. That eliminates 4 in the rest of the box. So this must be either 1, 2 adding up to 3 or 2, 3 adding up to 5. And we're guaranteed a 2 there. That means the remaining digits in the box are 1, 3, or 9, with a 9 guaranteed there. So 9 eliminates 9 in the rest of the row, or the rest of the column, I should say. We also have a 4, 5, 6, 7, 8, 9 sextuplet in row 1, which eliminates 4, 5, 6, 7, 8, 9 in the rest of the row, so this must be 1, 2, or 3. That 1, 2, 3 triplet eliminates 1, 2, 3 in the rest of the box, so this can't be 1, 2, or 3. This must be 4 and 5, adding up to 9. We also know 5 has to be one of these digits because it can't be one of those digits there. 9 has to be one of these 3 digits, so 9 cannot be here in the rest of this box. 5 cannot be here in the rest of this box. 4 also has to be one of these 3 digits here. So this cannot be 4 here, because there's no other place for 4 in row 1. Okay. What else do we have? This cannot add up to 9, so we can't have a 5 here. These are 2 digits here, which are consecutive, so it must add up to an odd sum here. But it has to be adding up to a sum that's divisible by 3 here. So it's the same for this. So these 2 digits must sum up to the digits that are 3, because, again, the middle digit must have 1 digit above it and 1 digit below it, which is, and if you sum them all up, it's basically the same as 3 times that middle digit. So these 2 digits must sum up to what these 3 digits sum up to. So the 2 digits are going to add up to an odd sum. And it must also be divisible by 3 because these digits must also sum up to that same sum. And there's going to be 1 middle digit, 1 greater digit, and 1 smaller digit, which is equal to 3 times the middle digit. So, what are the sums that add up to sums? So we can't really have 1 and 2 here because the minimum amount is 1, 2, and 3. That adds up to 6, which 2 consecutive digits cannot sum up to. 2, 3, and 4 add up to 9, which does not work because if this is 2, 3, 4, to add up to 9, it has to be 4 and 5, which are consecutive. And we already have a 2, 3, 4 triplet in that row. 3, 4, 5 adds up to 12, which is not an odd digit, which is not an odd sum, which 2 consecutive digits cannot add up to. 4, 5, and 6 is 15, which does work with 7 and 8. And I think that's the only possible solution. 5, 6, 7 is 18, which 2 consecutive digits can never add up to. It's too great. And then everything else is going to be a greater sum. So it has to be 4, 5, 6 adding up to 15, which 7 and 8 add up to. That eliminates 4, 5, 6, 7, and 8 in the rest of row 6. So that leaves us with 1, 2, 3, and 9. Remaining in row 6. And this digit is the same as that digit because of the way that these work, right? This digit is equal to the same sum as that digit, so it must be the same digit. This digit can be only 1, 4, or 5. The only digits remaining in this up box 2 are 1, 4, 5 because 2 and 3 are guaranteed on this Renban line. And so 1, 4, 5 is guaranteed to be there. Remaining digits of box 1 are 6, 7, 8, and 9. Oh, 4 and 5 as a pair eliminates 4, 5 in the rest of the column, so this can't be 4, 5, it's 6. That eliminates 6 in the rest of the row here. So this is 4, 5. Remaining digits in box 1, again, are 6 through 9. We have a 6, 7, 8, 9 quadruplet in row 2, which eliminates 6, 7, 8, 9 in the rest of the row. So there's no 9 here. Which means where's 9 in box 3? It has to be here. Okay, that eliminates 9 here, so it's 6, which is the sum of 1, 2, and 3 added together. That eliminates 1, 2, 3 in the rest of the box, so no 1 there. It's 4, 5 as a pair. That eliminates 4, 5 in the rest of the column. So no 4 here, no 5 here. And this is the same digit. So it's 4, 5 there. 6 eliminates 6 in the rest of the box. Oops. So this can't be 6 here. 9 can't be here because of 9 in the row. So 9 is guaranteed to be one of these 2 digits there. 6 eliminates 6 in the rest of the row here. So this is 7 or 8. So this adds up to either 3 or 9. So it's either 1, 2 adding up to 3 or 4, 5 adding up to 9. So we can't have a 3 there. Nine eliminates 9 here, so this can't be 9 either. Two eliminates 2 in the rest of this column, so this can't be 2. If this is 1, 2 adding up to 3, or this is 2, 3 adding up to 5, we are guaranteed a 3 on this regional Renban line. So that eliminates 3 in the rest of the column, so this can't be 3. If this were 1, this would have to be... This can't be 1 here, because if that's 1, this has to be 2, which is not possible. Hmm. Remaining digits, so this, though, what are the possible combinations here? Again, you could have 4, 5, 6 adding up to 15 with 7, 8 on the other side. I'm guessing that's probably not going to be the solution, but we can always think that that's a possibility. Again, these sums must be divisible by 3 because this is a Renban essentially on this side, and that's 3 digits, which has a middle digit, one that's greater than it, and one that's less than that, which is equal, if you sum them together, is equal to 3 times the middle digit. So 1, 2, 3 doesn't work. 2, 3, 2, 3, 4 could work. 3, 4, 5 does not work. 4, 5, 6 could work. So this is either 2, 3, 4 or 4, 5, and 6. Obviously, this can't be 6 because there's 6 in the column. So either way, we are guaranteed a 4 on this Renban. So if it's 2, 3, 4, if it's 2, 3, 4, that adds up to 4 and 5 here. If it's 4, 5, 6, that means this is 7, 8 as a pair. Okay. Hmm. Okay. If this were 7, 8 as a pair, that means in column 6, where is the 7, 8? Can't be here because of the 7, 8 pair in the box. Can't be here because of the 7, 8 pair in the box. And this is a 4, 5 pair. So both 7 and 8 in column 6 would have to be in that cell, which obviously is a contradiction. So therefore, this cannot be 7 and 8. It has to be 4 and 5, adding up to 9, which means this can't be 4 or 5 here. It's 2 and 3, and that must be a 4 here. And 4 eliminates 4 here, so it's 5 and 4. So we have 2, 3, 4, which adds up to 9, and 4 and 5, which adds up to 9. That eliminates 4 and 5 in the rest of the box. So this must be 1, 2, adding up to 3, or 2, 3, adding up to 5 here. So this is 3 or 5 with a 2 guaranteed here. That means this can't be 2 or 4. So to add up to 3, this is 1 or 5, which would force this to be a 2 or 4 here. Also, we have a 1, 2, 3, 4, 5 quintuplet in box 9, which eliminates 1, 2, 3, 4, 5 in the rest of the box. That means the remaining digits are 6 through 9 here. This can't be 9 because of 9 in the column. These two digits are the same digit, so make that pink. Actually, I guess we can make that blue. So that's blue, and this is orange. This is blue here. Blue means this can't be blue. That's orange, which makes that blue. So orange is one of these two digits there. 4 has to be one of these 3 digits. What happens if this is 9 here? If this is 9, that forces this to be 4 and 5. But this 9 eliminates 9 in the rest of the column. And then we have a 6, 7, 8 triplet here. And the 6, 7, 8 triplet eliminates 6, 7, and 8 in the rest of the column. And the 4, 5 eliminates 4, 5 in the rest of the column. So this cell would not have any possibilities then if this were 9, right? Then 4 and 5 would eliminate 4 and 5. And the 6, 7, 8 triplet, because of the 9 eliminates 9 there, eliminates 6, 7, and 8 as a possibility there. So this would have no possibilities, which is obviously a contradiction. Therefore, this can't be 9, it's 3, which makes this 2 and 1 adding up together. That means this cannot be 2 and 1 here. 1 eliminates 1 here, so this becomes 2 and 3, adding up to 5 on the Renban. That means this can't be 1, 2, or 5. It's 3 and 4. 3 can't be here because of 3 in the column there. So this is 3, that's 4, which adds up to 7 there. 7 eliminates 7 in the rest of the column, so no 7 there. 3 eliminates 3 here, so this is 1. This can no longer be 1 and 2. Adding up to 3, it's 2 and 3, adding up to 5. 3 eliminates 3. 1 eliminates 1 here. 3 eliminates 3 here, so this is 2, which makes that a 2. So no more 2 here, no more 3 here. It's 1, 9 as a pair. 2 eliminates 2 here, so that's 3 and 2. That eliminates 2 in the rest of the column here, so this can't be 2. It's 1, 3 as a pair. 1 eliminates 1 here, so that's 3 and 1. 3 eliminates 3 here, so it's 2 and 3. No 1 and 3 makes that a 2. This is blue, so this cannot be blue here. It's orange. That leaves that as a blue there. 5 eliminates 5 here, so the blues have to be 4. And this can't be orange anymore, so the oranges have to be 5 because we have a 5 there. Okay. Where is the 5 in box 3? Can no longer be here because of 5's in the column. Can't be here because of 5 in the row, so 5 has to be there. Where's the 4 in row 1? Cannot be here because of 4 in the column, so it must be here. So that's 4. Okay, remaining digits. So the rest has to be pretty much just normal Sudoku. Yeah. So, where... Oof. Fives. We have 8 5s. We know where the last 5 has to be. It has to be there. 4s. We have 8 4s. We know where the last 4 has to be. It has to be here. 3s. We don't. Okay, we have in box 5. Cannot be here or here because of 3's in the columns and 3's in the row. So 3 has to be there. Don't have enough information there. 2s in row 4. 2 cannot be here because 2's in the boxes, so 2 has to be one of these 2 digits. And to add up to the 9 correctly, we have to have 2 in one of those 2 digits in columns 2 and 3 in row 9. That eliminates 2 from the rest of columns 2 and 3 because we have 2 2's already accounted for in those columns. So these can't be 2, which means where's the 2 in row 1? It must be here, or column 1 either. Now we have 2 3's guaranteed in columns 2 and 3 in row 1 and in row 9. That eliminates 3 from the rest of columns 2 and 3. So where's the 3 in row 5? It has to be here. Remaining digits of column 1 are 1, 7, and 8. This can't be 7 because of 7 in the row. No 1 because of 1 in the row. We now have a 6, 9 pair left in box 7. And this can't be 6 because of 6 in the column. So this must be 6 here, which makes this 9. 9 eliminates 9 here. Remaining digits of row 8, we have 6, 7, and 8. We have a 6, 7, 8 triplet now in column 4, which eliminates 6, 7, 8 in the rest of the column. So no 6, 7, or 8 here, it's 9. That eliminates 9 in the rest of the box. And no 6, 7, or 8 here, that leaves that as a 1. 1 eliminates 1 here, so that's 8, which makes that 7, which makes that 1. And that leaves just a 9 remaining in row 7. No 7 here because of 7 in the box. And no 7 here because of 7 in the row. Remaining digits in box 8 are 6 and 8. We can remove the oranges and blues. You might need to use colors again. Remaining digits of box 5 are 1, 6, and 9. No 1 here because of 1 in the column. 9 eliminates 9 here. So where's the 9 in box 1? It has to be here. Okay, remaining digits of box 4. We have 1, 2, 7, 8. No 2s here because of 2s in the row. No 9 here because of 9 in the row. No 9. 9 eliminates 9 here, so that's 6, which eliminates 6 of the rest of the column. 6 eliminates 6 here, so that's 1, which makes this a 9. 9 eliminates 9 here, so that's 1. So 1 eliminates 1 in the rest of this row. So this is guaranteed to be 1, this is guaranteed to be 2. Well, one of these is guaranteed to be 1, one of these is guaranteed to be 2. Remaining digits in column 7 are 6, 7, 8. No 6 here because of 6 in the row. We have a 1, 7, 8 triplet in row 5, which eliminates 1, 7, 8 in the rest of the row, so that leaves this as a 9. 9 eliminates 9 in the rest of the column. Where is the 9 in box 9? It has to be here. That leaves this as a 6, 7, or 8 triplet here. Okay, we need to figure out this portion then. Maybe we choose these two to disambiguate yellow, orange. This can't be yellow, so that's the orange 7 or 8. Orange cannot be here, therefore orange is one of those two. Orange cannot be here, so orange is one of these two. Yellow has to be one of those two there. Orange cannot be here, so orange is one of those two. That's not helpful. Okay. What about this 7, 8 pair? Make that yellow and pink. Or maybe red. Yellow and red. So this is red. We have yellow here. This has to be the red, which means yellow's one of these two. Okay. Red is here, so red has to be one of these two. Ugh, this is not helpful. Um... Mm. Uh, hmm. Huh, I'm not sure how to actually finish this. Oh. I think we just have to try things. I don't really like that, though. Let's look at the 6-8 pairs. Maybe that'll give us something. 6-8, blue and green. This can't be blue, so that's green. Which means green cannot be here. Green is one of these. So then green has to be here. This green means that's not green, so it's blue. So green has to be here, which means this is green. Green has to be here then, as a 6 or 8, because those are the only possibilities. Which means this can't, yeah, the green here sees this green here. Or this cell here. And blue sees that cell there, so this must be green. Which is a 6 or 8. So 7 has to be here. And 7 means this can't be 7. So this is 8, and this can't be 8 or 7, it's 6. That means it can't be 6. So that's 7, which makes that 8, which makes that 7, which makes that 8. Okay, there we go. Still don't know which one of these are, though. No 6 or 8, no 7 or 8 here, it's 6. 6, 8 as a pair means this can't be 6 or 8, it's 7. 7 forces this to be 8. So then the greens are 6s. Because this can't be 8. So the greens are 6s, the blues are 8s. No more 7 here. No more 8s here. 8 eliminates 8 here, so that's 2 and 8. 2 eliminates 2 here, so it's 3 and 2. 3 eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 7 and 1. 8 eliminates 8 here, so it's 7 and 8. And this can't be 6 or 8, it's 7. That was actually, I feel, kind of the hardest part about this. Was disambiguating the 6, 7s, and 8s here. That was interesting. Yeah, because the Renban having to be on both sides makes things kind of restrictive, actually. So it was never that hard to figure out where to go next. But that was kind of hard to figure out for the 6, 7, 8 situation. I just had to find the right combo, and it was this 6, 8 pairs, right? So that was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.